नमस्कार, मैं हूं श्वेता. Welcome back to the CTET preparation series. So now today we are here with a interesting topic that is from CTET Science Paper 2, that is materials of daily use. So we'll try to understand this topic and also see what kind of PYQs were asked and also understand if the questions can be answered easily and what kind of tricks to remember for this one. So in this topic of materials of daily use, we have concepts such as chemical substances, acids, bases, neutralization reaction, plastics, what are the everyday use items that are there are all in this topic. So let us first go by understanding some basics about this topic, a small brief about a topic before going into the PYQs. So first we have in this one, we have to understand the basics of acids, bases and salts. So as we know, acids are sour to taste, and we have to remember that acids can be found out by litmus test. They turn blue litmus red. So we can remember by this one. And in bases, red litmus turns blue. So we can remember it like that. And when acid dissolves in water, they release H plus ions or they dissociate or ionize themselves to release into H plus ions. So this is one of the major thing that we can remember now. The same with bases. Bases have a bitter taste. They have a bitter taste or they have a soapy touch also. Even you can see in that case, and they dissociate into OH minus ions. Even in case of NaOH, you can see Na plus and OH minus ions dissociate themselves into OH minus ions. And they are specifically water soluble and are also called as alkalines. So alkalis. So we'll see if all the alkalis can be called as bases or all the bases can be called as alkalis or not in the coming slides. So there are something called as salts also. Now salts happen by the neutralization reaction of both acids as well as bases. Then we form salts. So they have distinct characteristics irrespective of the acid or the base. So let us see in detail now about the acids. As we are talking about the acids, we have talked about how they dissociate themselves into H plus ions, and there are something called as organic acids that are extracted from living sources, which especially are acetic acid, citric acid, tartaric acid. We have almost all carboxylic acids can be extracted from these organic acids. There are something called as mineral acids. So these mineral acids are nothing but the acids that are extracted from elements like from the earth crust, like hydrogen, sodium, or all these acids can be extracted from that. Now next we have to also remember some of the properties of the acids. So we know acids conduct electricity and they're highly corrosive, and they evolve hydrogen gas when reactive with active metals. So these also you can remember. They release hydrogen gas when reacted with metals. So this also we can remember. So there are certain classifications of acids here: organic, mineral, which can be remembered. And acids have very much use in the daily life also and in industrial use also. So we can remember the applications of acids. Let us again see how bases, alkalis, and the pH measurement and the indicators that can be used to understand which is acid and which is a base. So as we have told about, base have a bitter taste and they have they are soapy to touch, and they turn red litmus to blue. Now you can remember this one like in case of bases, they turn red litmus to blue, that is BB. So you can remember that as BB. So you can even see here, litmus turns basic in blue, so you can remember as B and B. And we also talked about how they produce hydroxyl ions or OH minus ions. And as we have already told about that, all the bases, when they dissolved in water, they are water soluble and they are also called as alkalis. Okay, but here there is one thing to remember, that not all bases are alkalis, but all if you see here, there is one base here, copper oxide, which is not an alkali. So this is one of the exception we have here. So you can remember that exception. Here all the alkalis are bases. So even that you can remember. We have many alkalis like sodium hydroxide, potassium hydroxide, all those we have some of the examples. Let us go into understanding the indicators that we have to identify acid, base. So most of the materials that we have is litmus, turmeric, phenolphthalein. Even we can use China rose or hibiscus. All those things can be used to find out which is acid or which is base. So to understand that, we have to know which of the indicator will behave in acidic medium and basic medium. So we have already talked like litmus turns blue litmus into red in acidic medium, and in basic medium red litmus turns to blue. So we have remembered it. In case of turmeric, in acidic medium it is yellow in color, and in basic medium it becomes reddish brown. Even when you have seen when you wash your clothes also, if any turmeric stains are there, they turn into reddish brown. Even you can remember in that way. And in phenolphthalein is one of the other indicator which stays colorless in acidic medium but becomes pink in basic medium. So these are the few of the things that we have to remember in case there are questions asked like there is X acid or Y acid or some X component or Y substance, both are mixed together, pink color is coming or reddish brown color is coming. Those kind of questions can be asked wherein you have to remember these things and you have to identify whether X is acid or Y is acid or based on that. So there is one of the important thing also, that is pH scale, which was developed by Sorenson. As we know, pH scale is from 1 to 14. Less than 7 can be considered as acidic, and more than 7 can be considered as basic, and 7 is considered as neutral. So this is the classification everyone knows. So depending upon this one, we'll classify acidic acids and bases based on the scale we have. So this scale basically measures how much acidic compound or a mixture is, or how much basicity a compound has, depending on that. So next we'll try to understand neutralization reactions. As we have talked about how salts are formed when acid and base react together. It's also called as neutralization reaction. Okay. Now we have to understand some real life applications of neutralization reaction. So when acid and base react together, they give us salt and water. Okay. And some of the real life applications that we have, one is majorly used for indigestion. What happens when our stomach produces hydrochloric acid for digestion? When some excess acid is produced, it causes pain and discomfort. So this can be neutralized by some of the antacids. The antacids are magnesium hydroxide and aluminum hydroxide. You can remember this is, which is a very easy one. Magnesium hydroxide and aluminum hydroxide. Yes. Then there is one more question regarding ant sting. If we see ants when they bite, they inject formic acid. So this can be neutralized by applying a base like baking soda, which is nothing but sodium hydrogen carbonate. So you can remember like this also. Real life applications little bit. And there are certain salts which are called as simple salts, like the one we have NaCl, which is combination of acid and base here again. Then we have something called as acidic salts. The example of acidic salt is sodium hydrogen and sulfate. Then there is something called as basic salt, that is sodium carbonate. And there is something called as double salt. So double salt is a combination of 2 or more elements here, and they exist in they actually stay in water, and that is the reason we write here 12H2O, like dot H2O. Then also we have and we move into discussing about synthetic fibers and polymers. So when we discuss about synthetic fibers and polymers which are used in our clothes, that we wear those clothes. So basically, if you see from the name synthetic, synthetic means they are man-made polymers, artificial ones which are man-made. And there are some examples of nylon. Nylon is a first fully synthetic material, and there is one more, polyester. Now polyester, as you know, it resists wrinkles. And there is one more important thing we have to remember: it's highly durable, as you know. You can wear it from many years, and it dangerously melts upon heating. You have to remember it. It is actually very dangerous at high temperatures. So, and there is one more synthetic fiber called as rayon. Now, rayon is it's prepared from a natural cellulose. That is from wood pulp. Usually, we prepare it from they prepare it from wood pulp. So, it is a natural. The source is from a natural source, that is a wood pulp. So the synthetic fibers here we have are nylon, polyester and rayon. So you can remember the things of nylon, properties of nylon: they are strong and elastic, polyester is wrinkle resistant, and rayon is coming from natural cellulose or wood pulp. You can remember it. Now let us try to understand the plastics that we have. So the plastics that we have are divided in 2 types: thermoplastics and thermosetting plastics. So here we have thermoplastics. They are actually a linear structure and they have weak intramolecular bonding forces. So there is a structure of it. And what happens when we heat these kind of thermoplastics, they soften very easily, and they can be remolded into some other shape. So this is the reason that they can be reused, because they can be remolded and they can be reused multiple times. And some examples I know, it is PVC bottles, Teflon, nylon, polyester, polythene. All those plastics can be reused or recycled because of this property that they can soften upon heating and can be remolded. Okay. Then we'll come to thermosetting plastics. Here the structure is a cross-linked. It's also called as cross-linked polymer, and it's a three-dimensional one, and they have strong covalent bonds. Now here you see there is a weak intermolecular structure, so it could be softened when they were heated. But here in this case they had strong covalent bonds, so even upon heating they do not soften. They just turn into black char or some kind of material. They will not be able to remold. So even that is the reason we are not able to reuse it. And some examples of thermosetting plastics are bakelite, melamine, urea formaldehyde, and epoxy resin. If you see, all the switchboards that we have are made from thermosetting plastics. And there is one more thing that we can remember is Teflon. So Teflon is known as a best plastic because it is resistant to all the acids and bases, and it's also used in the cookware. But in cookware, the whole material is not made of Teflon. This is thin coating on the cookware, a thin coating of Teflon in the cookware. So we have to also remember certain properties of these plastics, that is, they are resistant to acid and bases, then they have a non-stick surface, and all of these are poor conductors of electricity and poor conductors of heat, and they contain, and especially Teflon contains fluoride. So you can remember this one. So now that we have revised certain of topics we have just gone through, now let us start by solving the PYQs. So the question that we have is severe burn injuries are likely to be caused by fire accidents while wearing synthetic fabric rather than natural fabric. So the question here we have is about synthetic fabric. Okay, so what happens if we wear synthetic fabric when there are fire accidents? So if we prefer synthetic fabric over natural fabric and there is a fire accident, what might happen? So severe injuries might happen. So why does it happen? The question is of that. So we have to remember the properties of synthetic fiber. So we talked about how synthetic fibers, nylon, we have rayon, just now we have talked about polyester, we have. So if you remember, we talked about how they are melt dangerously at high temperatures, right? Here only we have talked about they are highly durable, that is true, but they dangerously melt at high temperatures. So what happens when dangerously melt high temperatures? They will cause severe burn injuries, and they burn into a sticky liquid. So it burns into a sticky liquid and causes severe burn injuries. So because of it, synthetic fibers are usually not preferred. So the main disadvantage of this synthetic fibers is at high temperatures they melt very easily and will cause serious burn injuries. Okay, so this was the question asked in 2022. So let us go to one more question here. The question we have is some acids are strong and some are weak. The strength of an acid depends upon certain ion produced in water. The ion is, yes, we know when any acid is met with water, they release H plus ions. So based on the H plus ions, we can find out the strength of an acid, how much strong it is or how much weak it is. So it is basically H plus ions. Okay, now we have one more question that is from 2015. It's regarding plastics. The common characteristic properties of plastic are. So we have 4 options and we have to choose which is correct among the 4. So let's go to see the 4 options. The first option is durable. Yes, plastic is durable. It is good conductor of electricity. It is non-reactive. Okay, so you see that you can eliminate because plastic is not a good conductor of electricity. So you can, this is property is not going. So you can eliminate this option. Next is it is durable, good conductor of heat, non-reactive. Okay, so even it is not a good conductor of heat, even you can eliminate this one. Next, third option is good conductor of heat, light in weight, good conductor of electricity. Since you have eliminated this and this, you can eliminate the third option also. Let us look at the fourth option, durable, light in weight, non-reactive. So you can go with this option or option 4. As we have talked about, and we have also told how plastics or polymers are poor conductors of heat and electricity. Okay, so we have seen the characteristic of polymer. Now let us go to understand some of the indicators. This was a question in 2016 that here was given. The question here is, indicators are substances that show different color in acidic and basic medium. Yes, that is the reason they are indicators. Based on this one, you will understand whether a particular substance is acidic or basic, because the same indicator is giving different kind of reactions in different liquids. Which of the following natural indicators turn dark pink in acidic medium and green in basic medium? So here they have given a list of indicators for us. We have to find out among this one, which of the indicators turn dark pink in acidic medium and green in basic medium. So you have to see the colors now. So let us go by eliminating the options one by one. Let us see which can be that one. Litmus, as we know, litmus paper, it turns blue in basic and red in acidic. So this is not the one. So we can eliminate this option. You know turmeric. Turmeric, as we have discussed till now, turmeric turns yellow in acidic and reddish brown in basic medium, right? Then phenolphthalein, as we have discussed, in acidic medium it is colorless, that is no color, but in basic medium it turns slightly pink. So see, if all these options are going through. Here in basic medium it is sold green, so we can eliminate this option also. We can eliminate even turmeric also. We can eliminate even litmus also. So we are left with China rose. See, China rose is something, it is the same specimen we can also see as hibiscus. So this is the option number 4. So you can remember even this indicator now, that is China rose or hibiscus. So what happens, it turns dark pink in acidic medium and turns green in basic medium. So you can remember even this indicator now. Okay. Now let us go to one more question that we have. It was asked in 2011. The doctor prescribes a medicine to treat hyperacidity. The main ingredient of the medicine is. So we have discussed about something called as neutralization reaction. So in that reaction we talked about how if excess of acid is produced in the stomach, that can be treated by an antacid. And we also talked about what are the components of antacid there. So if you remember, it was magnesium hydroxide and aluminum hydroxide. So here we have aluminum hydroxide. The answer is 4th option, as we have talked about. Even one more is magnesium hydroxide. We have discussed about this one also. So if you see there, if you see how the questions were asked, it was 2011 and this question was 2016. So did you see how the questions were not asked directly? As the years were passing, the questions are not being asked directly. They are asked in a twisted manner, right? So here we have from 2026, the recent paper. So here if you see, an aqueous solution X turns phenolphthalein solution pink, but on addition of aqueous solution Y to X, the color disappears. Which of the following is true among X and Y? Now we have to find out. There are 4 statements given regarding X and Y, right? Telling whether X is strongly acidic or strongly basic, Y is a weak base or Y is a strong base, all those things are given. And they have given something about X having pH less than 7 or Y having pH greater than 7. So there are questions, options given to us in this manner. So to answer this, we have to remember how indicator phenolphthalein reacts in case of acidic as well as basic medium. So let us recall how phenolphthalein reacts in case of acidic and basic medium. In case of acidic medium, phenolphthalein become colorless. Am I right? In case of acidic medium, it will become colorless. Correct? But in case of basic medium, it will become pink. So X turns phenolphthalein solution pink. So you can keep a guess, right? This can be a base. So let us again go to the next part of the question. But on addition of aqueous solution of Y to X, the color disappears. So now the solution has become acidic from basic. So there was some addition of acid, right? So now we can consider Y as an acid. So now which of the following is true about X and Y? So if you see here, X turns phenolphthalein solution pink. That is, we have decided it's a base now, right? Because we have remembered from the indicator. And now again when Y was added to X, the color disappears. Means Y should be very strong acid, that it should take away its basic properties completely. So Y is a very strong base. So let us see if we are correct or not. Yes. So as we have discussed till now, the option here, if we go back, we have talked about X being a base, right? So base means here, see, if options are there, X is strongly basic. Yeah, even this option goes. X has a pH less than 7. If pH less than 7 means it is acidic. So we can't take this option. X is strongly acidic. We can't take this option. So we can eliminate this option. X has pH more than 7. If X has pH more than 7, it's a base, right? So we can even consider these two options. So now we have 1 and 4. We have to filter among which is correct, 1 or 4. So next let us see about Y. In this question they told that when Y was added to X, the solution became colorless, means Y should be a very strong acid. So here in the first option that we have finalized from all the 4, they have given Y is a weak base. So we can eliminate this option also. So we can straight away go to answer 4. That is our this one. So if you see here again the same explanation is given. X turned the indicator pink, means it is a base, right? So we have finalized it was a base. Then again by adding Y, the color disappeared, indicating Y was an acid. So based on that we can make a conclusion. So this is how you can answer the question one by one. You have to go question part by part by solving one by one and then going to eliminate all your options. And be careful when reading the question, that is X has pH less than 7, greater than 7. All this you can just write this as acid whenever you have a doubt. So it can be easy for you, or you can remember this one. So it's a very easy question. The thing is the question will be like this, which will not be asked directly. Okay, so let us go to answer one more question of 2014. So here we have the question, a boy has a thick paste of turmeric. So they're talking about indicator turmeric here again. On adding this paste to hydrochloric acid, so there is something called as acid. Now let us remember what happens if in the case of the indicator turmeric, in case of acid, it becomes yellow in color. So we'll remember that. And an aqueous solution of sodium hydroxide separately. Now what happens if into indicator in basic medium, it turns reddish brown, right? What colors would he observe? Okay, so we have seen the question. They have talked about the indicator turmeric on adding hydrochloric acid. It's an acid. Turmeric behaves, turmeric is an indicator that turns yellow in case of acidic medium, and in case of basic medium, this is a base. Sodium hydroxide is a base. So it turns into reddish brown in case of basic medium. So we have 4 options here. The options are pink in hydrochloric acid and blue in sodium hydroxide, blue in hydrochloric acid and red in sodium hydroxide, yellow in both cases, yellow in hydrochloric acid and red in sodium hydroxide. So we have talked about how in hydrochloric acid it stays yellow and how in case of base it turns reddish brown. So our option is option number 4, right? So you can remember like this, and before proceeding we will also just recall that sometimes they might not give us the names of acid straight away like hydrochloric acid, sodium hydroxide. They might give us some fruits names also sometimes, and they can confuse us between the organic acids. So remember these things. In case of organic acids, we have citric acid, acetic acid, all those things, all the citrus fruits, all those things can be organic acids. And mineral acids, as we told, hydrochloric, sulfuric acid, all those things are there. So sometimes all these kind of questions might be asked. So even you have to remember, and you have to also make sure you identify which is a base and which is acid. Then only you will be able to find out in case of indicators how they behave. Okay, so again a quick recap of how all the indicators behave in each of the medium. In case of litmus, in acidic medium it is red, and in basic medium it is blue. Means in litmus here blue litmus changes to red, and in case of base red litmus changes to blue. And in case of turmeric as an indicator, in case of acidic medium it is yellow in color. In case of basic medium it is reddish brown or red in color. Here in the phenolphthalein, the one more indicator we have. In acidic medium it is colorless, in basic medium it is pink. Okay, so we'll go to solving one more question from 2012. So the question here is when carbon dioxide is passed through a clear lime water solution, it turns milky. So what is being passed? Carbon dioxide is being passed. CO2 is passed through a clear lime water solution. Lime water turns milky. So CO2 is passing through lime water. So you can just write an equation if you remember the equation. The milky appearance of the lime water is due to. So there is some product is formed. So you have to guess what is the product from the 4 options. So we can simply add the equation here as we have written here. Carbon dioxide is passed through lime water. Lime water is nothing but calcium hydroxide. So we have here the reaction takes place and we have here calcium carbonate and water. Right? So the answer is calcium carbonate. So the answer here is curdling of milk is due to lime in water. No, because of lime in water there is no curdling of milk. This is not the answer for this kind of question. This option is correct, but that is not the answer for this question. Presence of impurities in lime water. No, not the right option. Presence of insoluble calcium carbonate. Yes, this is the answer. If it is soluble, then it would not have been milky at all in the first place. So you can eliminate this option as well. Okay, so whenever these kind of questions are asked, straight away write the equation and you can get the answers. Okay, now some more important salts that we can remember is actually some of the salts are categorized into acidic, basic and double salts also. So one of the salt that you can remember is washing soda. Now washing soda formula is sodium Na2CO3.10H2O. So it is used in softening of water, removing hardness in the water. And there is one more salt that you can remember is baking soda. The formula of it is NaHCO3. And where is it used? It used in baking and also as an antacid property. And there is one more we have to remember is blue vitriol. Blue vitriol is nothing but copper sulfate pentahydrate, CuSO4.5H2O. It's actually used in agriculture to as a fungicide in various chemical processes. Even if you remember in the previous question also or previous video question, we talked about how CuSO4 is not edible. And there is one more, alum. Alum is KAlSO4 twice.12H2O. And it is very much important because it is used to coagulate blood and stop bleeding from minor wounds. So these are the important uses of each of the salts which were asked in the previous questions. So you can remember this one. And like this, if you find out any other uses, make a note of it. Okay, let us move to the next question that we have. It is from 2021. The question here is, why is a man-made fiber obtained from a natural source? What could be why? Now we talked about man-made fibers, that is synthetic fibers. So we talked about 3 synthetic fibers if you remember, nylon, polyester and rayon. So this can be any of this one. So, but we also talked about how there is only one man-made fiber which is obtained from natural source, that is cellulose, that is rayon. So that our answer is rayon, is straight away answer. So how is this rayon made? Usually rayon is nothing but the wood pulp which is obtained from the trees. Now after chemical treatment, they form a cellulose solution and they spin it and they get thin threads out of it. That's a rayon fiber that we have. So rayon is a man-made fiber. It's from a natural source called cellulose. Okay, unlike all the other synthetic fibers, remaining synthetic fibers are made from coal, water and all those petrochemicals. So that is the basic distinction between both of them. Okay, so yeah, as we have talked about, we'll talk about also natural fibers in this one. So natural fibers, as we know, they are obtained from plants and animals. So cotton is obtained from plants that it's grown in black soil. Jute is a very coarse fiber that we get from a jute plant. Then wool is obtained from animals. And there were questions asked regarding the process of obtaining wool, that is shearing, scoring, when is it done, the process or the steps behind it. Then we also know silk is obtained from cocoon, silkworms, herring and all those. And we just now talked about how man-made fibers 3 are there. And the major distinction between all this is the source from which they are obtained. Rayon is obtained from a natural source. But nylon is obtained from petrochemicals like coal. It is made from that. And the properties are, nylon is very strong. It's very strong. It's used to make ropes and parachutes, and it's a very high durable material which can be used. And later we know how plastics are there, how PET bottles we have, and how they are lightweight and they are being used every day in our life. So you can also expect some questions in environmental aspect of this particular chapter, because much of the things are regarding plastics and all the non-degradable plastics. So we can expect some of the questions from that angle also. So now next we have the questions from 2016. The question is select the true statement from the following. There are 4 statements given. The first statement is bakelite and melamine are both thermoplastics. Okay. So the statements has to do something with thermoplastics and thermosetting plastics. We have just discussed about that in the previous slides. We have talked about how thermosetting plastic and thermoplastics are different. Thermoplastics are something that are having weak intermolecular forces which can be molded very easily. So you remember that, right? So even we talked about the examples of thermosetting plastic. Thermosetting plastic, a cross-linked polymer. It's having very strong intermolecular forces, and they do not mold easily, and they'll turn into a black char if even we heat it. So you can remember all those things, and you can answer this question very easily. So when we talked about thermosetting plastic, we talked about the examples also. So if you don't remember, we'll just go by eliminating the other options. Next, melamine is a thermoplastic, whereas bakelite is a thermosetting plastic. We talked about how switchboards are made. Epoxy resin is one of the example of thermosetting plastic. So bakelite and melamine are both thermoplastics is a wrong option. Then we have melamine is a thermoplastic and bakelite is thermosetting plastic. The second part of it is correct, but the first part of it is wrong. So even this option also we can eliminate. The next we have bakelite and melamine both are thermosetting plastic. That's the two very correct option. The fourth one is bakelite is thermoplastic, whereas melamine is thermosetting plastic, same. So this is also wrong. So the answer we have is bakelite and melamine. It's a straight away answer where you can remember the examples from the concept. Okay, so let's move to the next question that we have. It's from 2022. The question here is these are 3 test tubes. There are 3 test tubes A, B and C containing 3 solutions. Okay. Now phenolphthalein is added to them separately. So there are 3 test tubes A, B and C, and phenolphthalein is an indicator that was added to all the 3 test tubes in a respectively separately. They were not mixed. Okay. Now A and B remain colorless, but C becomes pink. Now we have discussed about the indicators just now. In the case of phenolphthalein, is in acidic medium it is colorless, in basic medium it is pink. So C becomes pink means you can understand C is a base. Right? So it's a base. When C is added to A and B separately, so now they are adding C to A and B separately. A remains colorless. Okay. So A is remaining colorless means it is staying in acidic medium only. Right? So we can write A as acid. Right? And B attains pink color. B is attaining pink color. So if you see initially B was colorless, but when C was being added to B, it is becoming pink color, means it is attaining basic. It is turning basic. So the initial property of B should be, it should be a very weak acid such that just by adding of some amount of base is making it basic. So by this one you can categorize each one of them. Let us go again one by one, step by step. So here we have 3 test tubes A, B and C. So in that they have given that after they add phenolphthalein to A, B and C separately, A remains colorless, B remains colorless, but C turns pink. So by this one we can understand C is a base, right? Now again they have told us they will add C to A and B. So after adding A is staying colorless only. So it is pakka for sure it is acid. And it's a very strong acid because even after addition of that it is not changing. But C added to B it is becoming pink. Before it was colorless, but now it is changing to pink, means it is attaining basic property. Before it was acidic, now it is attaining basic property, means it should be a very weak acid. So now we will see the options one by one. A is a strong acid, B is a strong base, C is a weak acid. No, we can eliminate this one because, or we can do one thing, we have first finalized C as a base, right? We will check where are the options where C is a strong base. So we can eliminate option number 1. If you see an option number 2, C is a strong base. So you can consider this option. And in case of option 3 also we have C as a strong base. So we can consider this one. But in case of 4 we have weak base. So we can eliminate this one because when you are adding C to A, still it's staying colorless. If it's a weak base, it would have been not coming that property. So we can eliminate these two. So we can keep 2 and 3 as our after elimination our thing. Then again we have understood that A is acid. It's a strong acid because it is not changing its property even after base was added, right? So it's a strong acid. So A is a strong acid. Yes, in both of them we have, in this one we have it's a weak acid. So the answer here is 3, strong acid. So based on this one, we can answer all these questions like this. So if you see, the question was not asked directly, it was asked in a twisted manner where we have to find out what is A, B and C. Okay, and there is one more thing that you can understand is sometimes strong acid will resist some small changes even if you add a base also. Their property will remain as strong acid only. When weak acid and a base is added, the property might change to base because it's a weak acid. It is not able to retain its own property because it's being weak acid. So here if you see, strong acid resists changes with small amounts of base, but weak acids are easily neutralized by bases. That is the reason B was turning pink when initially it was colorless also. Okay, so now we have one more question, recent question. The question is which of the following statements about the process of obtaining wool is incorrect? Just now we have talked about in the natural fibers that how wool is obtained from sheep, the steps regarding it is important. Now we have the question here. So we have 4 options. Dyeing of different colors is done after picking out the burrs. So the burrs is nothing but whenever sheep goes out for grazing and all, it picks up plant things wherein some unclean items are there in the wool, which is not clean. Even whenever we wear wool clothes also, we can find out some kind of bulbs or some kind of things are coming up. So lint kind of things are there, that is called as burrs. You can understand that. Sorting is done after shearing. So there are some terms that we have to understand. They are talking about shearing, they are talking about scoring. So all these things. Now we have to remember, in the process of obtaining wool, there are some process where they take out wool from sheep first, that is called as shearing. That is first step. Then after shearing they do scouring, that is cleaning of it. This is cleaning. So if you see, shearing comes first, scouring comes next. Okay. Then after that they sort which one is good. Then after that they pick out the burrs. Then after that they again wash and again dried again. So this is the process of obtaining wool from animal. So now as we understood the process of obtaining wool from animal, we can easily answer these questions. Let us go back again by reading the options one by one. Dyeing of different colors is done after picking out the burrs. Now after picking out the burrs, they again score it, means they again wash it and again dry it. So this option we can eliminate. Sorting is done after shearing. After shearing we straight away do scouring, we wash it. So even this option we can eliminate. Next is shearing is done after scoring. Okay, even I read the question wrong. It is incorrect. So they have asked us to found the statement is incorrect. So now dyeing is done, dyeing of different colors is done after picking out the burrs. Okay, so shearing is done after scouring. So first okay, so first we have is shearing is done after scoring. No, first scouring is done, then we have shearing. So here the option number 3 is correct. So let me also check this option once again. Yeah, so here we have the concept breakdown of this particular question. So let us see the question again and go back to answering this question. So first, as we talked about the process of obtaining wool, we talked about how first they remove the wool from the sheep, that is shearing. Next they wash it and clean it, that's scouring. Then they sort it. Depending upon the material they separate it, because different depending on the quality they separate it, that is sorting. Then they pick out the burrs, some impurities or something they pick it out. Then they are scoured and washed again. Okay. So here if you see scouring is washing. So we'll go back. No, shearing is done. Shearing is nothing but removing the wool. That's the first step. So shearing is done after scoring, not scoring is done after shearing. So this is the incorrect option. So let us again start from the first. Okay. So again let us start from the first. We are seeing here dyeing of different colors is done after picking out the burrs. That can be done. Sorting is done after shearing. Yes, sorting is done after shearing. See here, sorting is the third option. Shearing is removing the wool from the sheep. So this is also right. Now this question is about incorrect. So this is also right. Now we also have shearing is done after scoring. No. First shearing is done, then scoring is done. So this option is, this statement is wrong, but this option is correct. So this is how we can identify the answer. Even I was confused when I didn't see the correct one. So whenever we read the question, straight away, instead of jumping to answer the question like what I did right now, you can just read the question once again and highlight whether what they're asking is incorrect or correct. Okay. So so now we have come to the end of discussing about the PYQs. Let us just sum up about what the things we have learned just now in this one. We have talked about acids, bases and the indicators, how each indicator behaves differently in acidic medium, basic medium. We talked about the indicators of turmeric, we talked about China rose, we talked about phenolphthalein, we talked about all those indicators. Then we talked about neutralization reactions, how it can be applicable in the application level of antacids and all, how fibers are there. Rayon is a naturally obtained source, that is a man-made fiber. We talked about how nylon is different from all the other fibers, and we talked about thermoplastic and thermosetting plastics, how they are different in each of them. We talked about the properties of plastic. So the major thing that you can remember here is, even in case of metals and non-metals, in one more basic thing in acids is the non-metal here is here when we have NO3, this will hydrolyze and give you nitric acid. In case of metal oxides, we can take NaO. If the hydrolyze, they give us bases NaOH. So you can remember this also. These kind of things can also be asked. So you can remember all these things where non-metal oxidizes to form acid and a metal oxidizes to form base. Sorry, metal oxides when they react with water form base, and non-metal oxides when they react with water form acids. So till now these are the topics that we have covered, and most of the questions, as you have seen, were asked in a very application level and some were asked directly. But now since they are shifting towards application level questions, so you have to be careful in answering all those questions and read the question properly, whether it is correct, incorrect, true, not true. All those things have to be highlighted before answering the question. So by this we come to the end of the discussion about materials and their daily use. So thank you so much. We'll see you again in the next video.